Hi, welcome to another Hopper tutorial style getting started video. I'm going to talk about the file system. This is Hopper's a modern curly brace and semicolon language similar to Java or C#, but designed to run on small devices like 8-bit CPUs or microcontrollers. On the microcontrollers, specifically, I'm connected to a Raspberry Pi Pico right now. We take some of the flash on the device and we configure it as a flash drive using LittleFS, a library on the devices, and then we have 3 units that use LittleFS. There's a path unit, which is really just a string manipulation unit, and it's all written in Hopper to do things like get your file extension, get the full path from a name based on the current folder, etc. Combine 2 paths, so it'll glue 2 path bits together and make sure there's only a single slash between them. Get the directory name from a path, get the file name from a path, check if something's a valid path character, all that sort of thing. And then the other 2 are file and directory. And they're very similar to the C# or Java file and directory classes, which have a whole bunch of static methods to operate on files and directories, with one exception, and that's that there are no exceptions. Hopper doesn't have exceptions, so it means that these file APIs can never fail. So they do never fail. They never will they'll never crash. They'll just, if a file API didn't succeed, then the file object becomes invalid immediately. So you can check if the file object is valid or not to tell you whether the operation was a success or not. And I'll illustrate that later in this demonstration. So first thing I'm going to do is I'm going to list the directory structure of the file system that's on the Raspberry Pi Pico with what's in there by default. So I have this method at the top here, list directory, which is recursive, it calls itself. And for each directory, it opens the directory path, counts the number of subdirectories, and counts the number of files in that directory. It then iterates through the indices of the files, prints out the file name for each, gets the size of the file, prints out the size of each file, and then it'll iterate through subdirectories and do the same. It also prints out the name of the current folder that it's in here. So let's compile that. That's F7 to compile. And then, so the shortcut keys are here, and then F5 to launch the debugger. When I launch the debugger, the title bar changes from blue to green. And it says here that it has successfully uploaded littlefs.hex. I'm going to go back again and show you some options. One of the options, if you upload to your microcontroller, you need to generate an Intel iHex format file. So it'll convert the regular executable, which is at the bottom of the screen here, the LittleFS hexy, Hopper executable. It'll convert it into a format that can be transferred to the device. So let's do that again. We run here, and at the bottom of the screen, it's successfully uploaded that Intel hex file to the device. This black area on the right here is the serial connection to my Raspberry Pi Pico. So if I F5 to execute now, I should get a directory listing of of what's on the device, and there we go. So let's talk about this a bit. I'm indenting by 2 characters every time it recurses. So in the root directory, which is the / here, all the directory separators are always a single /. There's no spaces in path, there's no spaces in file names. Those are Hopper constraints. The file system is case insensitive. And the way I implement that, because, for example, LittleFS is case sensitive, I just always lowercase everything. And hence, it doesn't matter if you used an uppercase or a lowercase character. Like here where it says data with uppercase, it's not going to matter. It's always just going to lowercase it. Alright, so inside our root folder we have a bin folder and a temp folder. These are always created by default by the system because it uses them. And inside the bin folder is something called auto.exe. And this upload of your current program is actually always called that. It always renames it to auto.exe. And that's the size of this binary file that we're actually running right now. And the reason for this to exist is so that if you take the power out of your microcontroller and then you put the power back on your microcontroller, it'll automatically launch a look in bin, see if there's an auto.exe, and it'll run it if it exists. So if you've already got a program on a Hopper program on your microcontroller, you don't have to reload it. Obviously that would not be great. So it works a little bit the same way as loading a program onto an Arduino. Okay, so we've seen how the file listing works with the default folders. Right. Now, I've made a sample file. If you've watched some of my other videos, you'll recognize it. It's just a text dump of my usual of Gordon Henderson's Mandelbrot. I can put it in the editor; it will be easier to see. So I just made this file as a data file to test and show. Now, in addition to the debugger, there's also a tool called the Hopper Monitor, Hoppermon, and I can connect to the Raspberry Pi Pico from the console using that. So it's now connected to the Raspberry Pi Pico. MCU is telling me it's connected to a microcontroller rather than to a 6502 or Z80 device. If you put a question mark here, it tells you what all the commands are, all the help. And if you're on a microcontroller with LittleFS, the T command will transfer a file. So let's use it. So T space, and then we're going to type in the name. It's always uppercase over here, which is a little bit convoluted, but that's our file. And then the second argument here is the folder we want to put it in on the device, and it's enough just to do that. I could put subfolders in too, but I won't bother this time. And then it's now uploaded it. I've tested this with reasonably large files. I inject a little delay every so often to let the serial port catch up, but I've uploaded pretty large files. Alright, so now we should have that file on board. And I can just load LittleFS here and run it. So that uploads, so L for uploading a Hopper program, the hexe file, up to the device. And then if I run it here, we can now see the directory listing. And it's now got a data folder with mandelbrot.txt in it. If that's confusing, let's go have a look at it in the other one. So if we go edit LittleFS, and we run over here, same thing. So there we go. The listing now has a new folder in it with our data file has been uploaded, and it's telling us how big it is. All right. Let's change this, and let's Alt F4 out of that, and we'll tell it. Let's show that file. I've written a little function here which will open the file from this path, read all the characters, and show them on the screen. And this is actually a good time to talk about is valid. So let's build this. This is the typical loop for reading from a file. And it's not a while loop. It's not while is valid. Because if you go while is valid, you won't get... how would it work? So the way we know that we've got to the end of the file is we go if read, and if becomes invalid on the last character. So inside here you need to check if it's valid anyway, because if if went invalid, you shouldn't print out the character you got back, because it's going to return probably a 0 if has gone invalid. So you'd have to put the extra check anyway. You could go while is valid there, but you also have to check if valid before you print, so you might as well just do it once. Anyway, this is typically the pattern I use to iterate through all the content of a file and output it, and break out of the loop when if turns invalid. Alright, so if we do that, and we load into the debugger, bottom of the screen it's successfully uploaded. If I F5 here, it does the listing now followed by the Mandelbrot, which doesn't look so great here. But there's a couple of other ways we can run it, so let's exit out of there. We can go to the console, and we can go Hoppermon, and we can say load LittleFS, upload successfully, and then just F5. So it iterated and showed us the directory listing, and then it went and loaded up that file Mandelbrot from the flash and printed out all the characters. All right. One more thing before I shut down, before I'm done with this video, and that is I made a delete directory method. Let's build it. So preprocess compile, it's successfully compiled at the bottom. So very similar to the listing, except that I don't delete inside the loop. I build up a list of file paths. So I've got an empty list here when I start, and for each iteration through the index where I get the file name or the file path, I append it to my list. Why? Because if I delete it here, it would change the number of files in the folder, and that would cause this index to be bad. So you could just always delete. Another way to do this is to delete the file at index 0 until file count is 0. So you could do that as well, but I just built a little list, and then once I've iterated through all of them, I then iterate through the list and just delete them all by name, and that kind of works. Very similar with the folders. I iterate through them recursively calling delete directory here. I'm also adding them to a list, and then once I return from all those recursive calls, that means during the recursive calls it's going to delete all subdirectories, delete all files. Once that's happened, I come back, I recurse through my list, and I delete them. So let's run this. Load it into the debugger, bottom of the screen here, good to go. Press F5, it's deleted everything. So it deleted my program that's currently running too, because it's in memory, it doesn't matter. So it's on disk and in memory. Deleted my Mandelbrot and then deleted all the folders. Interesting thing, if I run it again, let's see what's going to be the case. It keeps deleting them again. And that's because the system keeps adding them back. If I go debug reload, I've uploaded the hexe file again. If I now run it again, it deleted the hexe file again because it uploaded it again. Anyway, you get the idea. That's all for now for this video. You should know now. Oh, there are other ways to upload to your LittleFS file system on the flash on your Raspberry Pi Pico. For example, there's an option somewhere in the Arduino IDE to do this, to upload files to your LittleFS. One of the problems with it is that you might upload something that conflicts with Hopper's constraints on paths and file names. Like you might upload something with an illegal character that Hopper doesn't understand as something that belongs in a path or a file, like a space character. You might also upload two different file names with to the same file, or two different cases of the same path name. And there's another bit of trickery as well, and that's that LittleFS has a, in quotes, feature that if you delete all the files inside a folder, then the folder disappears, which can be quite confusing. So the way the Hopper file system works in conjunction with LittleFS is it actually puts an invisible file with an illegal character. It's actually the name of the file is a single underscore, and it uses that to stop LittleFS from deleting the directory if it's empty. So that's why I thought it wise to make our own utility, and this utility is a little bit rough around the edges right now. This transfer utility, I'll just leave it on a screenshot of transfer. So and it's doing this from the current folder. That's taking a file from the current folder. So if you wanted to use this, you'd have to switch to the current folder to upload a file. So mandelbrot.txt to data, and we load. I don't do any checksums to verify that the file was correctly uploaded yet. I've just finished this feature today. Strictly speaking, I should make it a little bit more robust, but that can wait. First we get it working, later we make it better. Anyway, thank you for watching, and I look forward to your feedback.